already in the other parts of the review have talked about integration. About derivatives. So now we need to talk about integration, kind of the last part that will be on the test. Let's take a look at 58A. Now, if we start with 58A, the first thing I would recognize is that I have something stuck in a fourth power. So I either have to multiply all that junk out somehow, or I need to use u-substitution. So this is one where you are going to make u the thing that is stuck. So if we make u the thing that is stuck, the rest of the problem contains an x dx. So we need to figure out what is x dx equivalent to. So you are going to differentiate this. Whatever you get, we need to make one side equal to x dx. We make the other side all the other stuff. So we're going to get 1/6 du is equal to x dx. That means in the problem, we get to substitute in for the x dx, 1/6 du. The stuff that was stuck is what we made u, so now the stuff that's stuck becomes a u to the fourth. Now we do use substitution to find the integration or the antiderivative of a more difficult problem in a simpler way. So if we take the antiderivative of that, we get 1/6 u to the fifth over 5 plus c. Now I would write that as u to the fifth over 30. We are not done until we put the x's back in. Remember, x was or u was equal to 3x squared plus 4. That's the thing that was stuck. So that is your final answer. How can we check our work? I would like to check the work because you guys are getting answers without even thinking about the fact that you have a perfect way to check your work. The derivative of the integral is the function that you had originally inside. Because if I take an antiderivative and then I do a derivative, it should go right back to the original form. So if I do the derivative of that, the 5 drops down in front. The stuff stays there. The power goes down by 1. We multiply by the derivative of the inside. Now, let's think about how that is the original answer. 5 times 6 is 30. The 30s are going to cancel out. Inside the integral, did we have an x times the quantity of 3x squared plus 4 to the fourth? We sure did. So if you do the derivative to the answer of an integral and you do not get the function inside, you did not do the correct antiderivative. You can check every integration that way. If a test is multiple choice, could you, if you didn't know how to do the integral, just keep doing the derivatives until you get the one that's the function inside? Yes, you could. Is that more time consuming? Sure, but you have 2.5, 3 hours tomorrow to do it. Yeah.
How many questions are on the test?
How many questions are on the test? 25.
I thought it was 35.
She told us 35, but
It's the juniors. The trig one is 35. Okay, now let's do B.
Is there multiple parts to each question?
No. Okay, let's take a look at B.
now they're all just going to be in one single part.
Okay, so in B here, we have something stuck to the third power. Then you got to think, is its derivative or something like its derivative sticking on the outside? Well, sure. The derivative of something to the fourth power is the third power. The derivative of an x is just the number. That's just a number. Odds are that this is what we're going to make the u. So we're going to make u equal to 2x to the fourth plus 4x. Now, remember what we need. We need the 2x cubed plus 1 dx to be something that is in our substitution. So this is going to be 8x cubed plus 4. Now, if we compare that with what I've highlighted kind of in that purple color, what could we divide 8x cubed plus 4 by to turn it into what we see in purple? What could you divide by? We could divide by 4, right? So let's multiply each side by 1/4. Move that dx over. And we get that 1/4 du is equal to exactly what we want. Okay, so now let's look at the technique that we're going to go from here. I do not know what just happened. Anyway, guess I'm not moving that. Anyway, so let's go ahead and do our substitution. We're going to get a u to the third. We need a 1/4 du. The antiderivative of a u to the third is a u to the fourth over 4 plus c. We're going to put our u back in as it originally appeared. So that's going to be the stuff, 2x to the fourth plus 4x to the fourth over 16 plus c. We could check our work. We could check our work. If we did the derivative of that, we would get exactly what is inside the integration. Everybody good with B? Okay. Now let's take a look at C. We're not going to do D because it's just very repetitive. C and D are very alike. The only difference, C does have some boundaries of integration. D doesn't. D, you would just give the answer plus C, the antiderivative. C, we do have to plug in some numbers. Okay. Now, for C, just like integration or derivatives, just like derivatives, a rewrite can be extremely helpful. So when we see this, the fact that this is only one term means that I can technically divide it through. So the first thing I'm going to do for C is I am going to divide that through. So I'm going to make that 2x to the negative 2 plus 3x to the negative 4, because you're just subtracting 5 from the original exponents, plus 5x to the negative 5 dx. And because that's a polynomial-ish sort of thing, or a power function list, we can just go ahead and do the antiderivative, okay? So that's going to be 2. Now you're adding 1 to the negatives, so they feel a little funkier, but negative 2 plus 1 is negative 1. Negative 4 plus 1 is negative 3. Divide by that negative 3. Negative 5 plus 1 is negative 4. Now, I would make that as pretty as you possibly can before you actually plug in those boundaries. So I would make this negative 2 over x. I would make this one negative 1 over x cubed. The 3's cancels, but the negatives do not. I would make this negative 5 over 4x to the 4th. Okay. If we plug in 2, we get negative 1 minus 1/8. What's 16 times 4, people? 64? So that would be negative 5 over 64. If we plug in 1, we get negative 2 minus 1 minus 5/4. For a final answer of 195 over 64. So those are, just integration. I don't know, I would suggest practicing. Practice ones that you already have the answer for. There is a detailed solution I have posted to this. There is a YouTube playlist, I think, from YSU that they have done. Every video only contains, I think, like one problem. So there's tons of videos, but there are videos out there you can practice. And any of the old ones we've done. Okay. Now I would like to keep going. I would like to do problem, well, let's just keep going. Let's do E. This is a u substitution hidden a little bit. Because the derivative of an x is 1, there is a 1 always in a problem if you really want it. So we are just going to make the u the thing stuck inside our square root. So I would also think about this as 12 minus x to the 1/2. Any rewrites we did for square roots before, do those rewrites now. Okay. So we're going to make u 12 minus x, du dx is negative 1. Now there's not a negative 1 sitting on the outside of that, so we do have to divide both sides by negative 1. But there is a dx there. Dx is equal to negative 1 du. So our initial numbers are x's, so please remember those are x's. So don't substitute them in until they're x's again. But if we do our u substitution, we get u to the 1/2. You can put the negative out in front or on the u, it doesn't matter. To make the antiderivative of u to the 1/2, the power goes up by 1, it becomes 3/2. We have to multiply by a reciprocal of 3/2 or 2/3. Don't forget that negative that was there. We can change our boundaries for this one. We know that u equals 12 minus x. So if x is 8, we get 4. If x is 3, we get 9. So we can change those boundaries so we never have to deal with x's again. That's one great thing about u substitution for a definite integral is the numbers, we can change them to u's and never have to deal with those again. Okay, let's put the u's back in. If we do 4, that's negative 2/3, 4 to the 3/2. That is a 4, it doesn't look like a 4. But minus negative 2/3, 9 to the 3/2. Now let's debate what those things are. 4 to the 3/2 is take the square root of 4, get 2, cube it, you get 8. So that's negative 16/3. Two negatives make a positive. Do the same thing to 9. The square root of 9 is 3 to the 3rd is 27 times 2 is 54. I don't try to reduce them even if they can because they should have common denominators at this point. 54 minus 16 is 28. Is that correct? 38? 38 thirds does not reduce, so you're stuck, okay. So that is E. I don't think we have to do F. It's very similar to one we've done before. I don't think we have to do H, but I do want to do G.
Could you zoom back in on that?
Okay. Yeah, let's do G next. We'll do G next. Well, G is very much like E. Let me just tell you the substitutions for each of those, and then we should be good there. In F, make your U the thing that's stuck inside your square root. G, make your U the thing that's stuck in your fourth power. H, make your U the thing that's stuck in the bottom. So that should help you there. These, again, you have detailed solutions, so you can check your work and work over any of these. The best way to study for a math test is to do math. Tonight, do lots of derivatives and lots of integrals. Do the basic ones and do more complicated ones. Don't forget implicit differentiation. Don't forget the hardest kind of integration are the u-substitutions. Okay, so that should get you kind of integration for those. Let's talk about these ones. These later ones are all u-substitutions. Let's do one with trig involved. Let's do M and N. Let's start with M. We have a cosine of x over 3 stuck inside of a cube. The derivative of a cosine is a sine, negative sign, you know, but I see that in the problem, so I think that's a really good choice for my u. It should work out okay. Well, du dx, now here's where it gets a little complicated. That's a chain rule. It is a negative sign of the stuff times the derivative of the stuff. The derivative of x over 3, because that's really 1/3 x, is just 1/3. Now, we don't see a 1/3 in the problem, so we do have to divide it off. To divide by 1/3 is the same as multiplying by 3. So we do get that 3 du equals, oh, and we don't have a negative. So let's put the negative in the 1/3 to the other side by dividing them off, and we get sine of x over 3 dx. So let's look at what we have for a moment. We found the u. It's going to go right there. We found what sine of x over 3 dx was equivalent to. It's equivalent to negative 3 du. So now we have a very nice, easy integration once we substitute in. We're going to put, I like putting the negative 3 out in front. Just remember, it just kind of hangs along for the ride. We're going to have a u cubed du. And that's a great integration. It's not a hard integration. We're going to bring the power up to 4, divide by 4. This does not have boundaries, so we have to put the u back in. Remember, we made u equal to the cosine of x over 3. So your final answer is negative 3, the cosine of x over 3 to the 4th, all over 4 plus c. How could we check our work? The derivative of that should be the function inside. The derivative of that should be the function inside.
Your unit's on here. No. Okay.
Okay, I do want to do n now. You will have to know your derivatives of your trig stuff. So if you don't remember those, your little card, write it down. Let's talk about the trig function derivatives. The derivative of a tangent is a secant squared. So although it appears as if our secant is stuck, that is not the u-substitution for this problem, because the derivative of a tangent will be a perfect replacement, because the derivative of a tangent is a secant squared. So in this particular case, although it seems a secant is stuck, we actually are going to use the tangent as our u. Now there is an alternative. You could have written secant as secant, and then what is the derivative of secant? Secant tangent. It actually works both ways. So we know that du is a perfect replacement of secant of x squared dx. So it just becomes the integration of u du. Very simple integration. It's just u squared over 2. Now, you do have to put your u back in as x's. Where we see a u, we need to make it a tangent. So that's tangent of x squared over 2 plus c. So that one looked weird, but it's not too bad. Okay. So those are those. I would like to do the area between two curves, so we will do some of that. I do want to talk about the derivative of an integral. Any questions about m or n? Okay, let's talk about 59 and 60. So those are the last ones we're going to do today. 59, let's think about something. Mathematically, if I multiply by 2 and then divide by 2, what have I accomplished? Nothing. If I take the sine of an angle and then take an inverse of an angle, I come right back to the angle. If I am asking to find the derivative of an integral, I am asking you to find the derivative of an antiderivative. So it should just be, these should be the easiest problems on the test. Because the answer to this, if the boundary is just an x, is just x squared minus 8. That's the answer. Now, if you get stuck, what you can do is you can evaluate the integral. You know, it would become t cubed over 3 minus 8t. You could plug in x in 3. You could get the answer to the integral, and then you could just take the derivative. But you'll get x squared minus 8. Okay? So you can take the integral, get an answer, and then take its derivative. You will get x squared minus 8. So there is a shortcut there. Just kind of like similarly that limit that said like sine of x plus h minus sine of x over h was really just saying take the derivative of a sine. It's kind of like just recognizing the rule. This is a perfect example of that. Now you have to be careful for b because it's technically a chain rule. Now let's think about why. If I took the antiderivative of this, if I did the integration rule, I would then have to stick in x squared. So that's where it gets funky. So the only difference here, you still just write the function inside, but you plug in that upper bound of x squared. But you just have to multiply by the derivative then. That's the only difference. That is the only difference. And the reason would be is, you know how you do the antiderivative for the integration? You would stick in x squared as one of our boundaries. Think about what would happen when you did the derivative next. You would do the derivative, you would have to take the derivative of the inside, the 2x would then appear. So you just have to remember, if your boundaries are an x and you're taking the derivative, it's just the function inside. If the boundary is a function of x, you do just stick in the function of x, but don't forget the derivative of that function. Okay. And then the last thing I want to talk about is the area of the region bounded by y equals x squared and y equals x to the fourth. For these, knowing what the graph looks like is very essential. Y equals x squared and y equals x to the fourth look very, very similar. They both kind of look like this. I can't draw. But they both kind of look like parabolas. What happens is the x to the fourth is just a little deeper than the x squared for the fractions. And so it does create this little pocket. Excuse me. So I want to draw the graph. And I want to draw the graph just between -1 and +1, because x squared equals x to the fourth. Intersects in 3 spots, at +1, -1, and 0. So we do have to know where they intersect to see what's the region I'm most concerned about. Okay. So at 0, they're both at 0. At 1, they're both at +1. At -1, they're both at -1. So we need a little bit more information. Okay, let's think about if we square 1/2. If we square 1/2, we get 1/4. So our parabola, the x squared one, looks like that. But let's think for a moment if we 4th power 1/2. If we 4th power 1/2, 1/2 times 1/2 times 1/2 times 1/2 is 1/16. It is much lower right here. So we do get a little pocket. The pocket over here, if I were to graph it right, and the pocket over here are exactly the same thing. So here's what I'm going to do. The area between these two curves, I'm going to double the area from 0 to 1. Just because of the fact that they are both even functions, they both have y-axis symmetry, so the area on the left side of the curve is exactly the same as the area on the right side of the curve. Okay? Which is our top function, the parabola or the 4th powered, the quartic I think it's called? Is the parabola on top or is the 4th power on top? The parabola is on top. Remember, it's always top function minus bottom function. Now, if they switch places at any moment, we do have to break up the integration into the places where they switch over. Okay. But let's think how easy that integration is. It's just x cubed over 3 minus x to the 4th over 2, no, over 4, all times 2. Now, let's plug in 1. If we plug in 1, we get 1/3, 2 times the quantity of 1/3 minus 1/4. If we plug in 0, we do get 0. But some of you on our last integration test assumed that when you plugged in 0, you got 0, but for the cosine of 0, what's the cosine of 0? 1. So don't always assume that when you plug in 0, you get 0. Maybe, maybe not. Okay. So this really becomes 2/3 minus 1/2. If we get common denominator of 6, that is 4/6 minus 3/6, or 1/6. So that right there is the last problem that Mrs. Haught is going to teach you in calculus this year. You didn't know that it was like, isn't that so sad? Isn't that just
It's
horrible?
not sad, but it's
That is
weird.
the last problem. Okay?
Watch movies.
So there you go.
Yeah,
There you go.
movies.
There you go. There you go. There you go.
Not if I watch
It's
one
been
of
a
your
it's
videos
been a
today.
joy. It's been a pleasure. It's been a joy.
Not if I watch